Algebra 1 students, and welcome to lesson 2 of Unit 1. In this lesson, we are going to be adding and subtracting real numbers. So as you can see, our objective is then I can add and subtract real numbers. So this is going to be any of your integers, whether they're positive, negative, decimals, so on. So we're going to go through 4 different examples on this. I know that we had practiced my Excel topic on this as well, but it is a good reminder to remember our rules too. So then we will also review those rules as we go through these examples. All right, make sure at any point if you feel like I'm going a little too fast, you can always pause it. That is at your discretion. You can write things down as well if it's going to help you remember. And we will do our assignment together tomorrow in class, or probably by the time you're watching this, will actually when we do stuff on Thursday. So our first example is to add and subtract numbers on a number line. So we're going to use a number line for each one of these problems to help aid us in solving this problem. So the first part is setting up a number line. So I'm going to set up a number line, and I will show you here in just a second. Before, I'd already taken the liberty to go and make a number line for each one, just so it's a little easier so I can explain. So let's go ahead and take a look at A. So for problem A, it says that I have -3 plus 6. So if I'm using a number line, I'm going to start anywhere, or my problem at 0, no matter what it is, whether it's addition or subtraction. And I'm going to go to whatever this number is. And so in this case, -3 is to the left of 0. So we're going to move our arrow this way until we're at -3. From there, though, I want to add a positive 6. And so adding a positive 6, remember anything positive is going to move in the right direction, towards the right. And so we're going to go back 6 to the right. So we're going 1, 2, 3, 4, 5, 6. All right, and so we end up at 3, so our solution will be 3. So -3 plus 6 is a positive 3. So let's go ahead and try for then B. So B, I've got -2, so let's start at 0 and go to -2, so that's going to be to the left. Now we are minusing a -9. Well, technically a -9 would continue into the left direction, but I'm subtracting it. So something I learned in my old school was that if you take this, okay, there's 2 different lines and then minus a negative. So what you do is you move one of those lines upward and you make instead of having this, you have a boom, boom, an addition, or they called it a shushing. So they'd be like, oh, you just take the 2 and make it into a positive because it takes 2 lines to make a positive symbol. So we're actually going to move this because it's going to end up being a positive, adding a positive 9. So we're going to move this actually to the right side. So we're going to move 9 to the right. So 1, 2, 3, 4, 5, 6, 7, 8, 9. All right, and we end up at 7, so our final solution then is 7. So that is one way that you could solve out problems like this, is using a number line to help you solve out the problem. So let's go through and review some of our rules. So the first one I want to talk about is the absolute value. So remember that if you have an absolute value, the absolute value of a number is its distance from 0 on a number line. So basically, if you've got these little lines in front of it, whether it's positive or negative, maybe I have a -2 this time, okay, everything is then going to become just how far away it is from 0 on the number line. Well, if I had -2, well, -2 is 2 places. So it is a positive 2. Basically, I kind of like to use the analogy that it's like a shower, okay? So here's your little shower walls. If you are positive, if the number is positive, you're clean. If the number is negative, then the number is dirty. So if you go in a shower, if you're clean, you're still going to come out clean or positive. If you are negative or dirty, you're going to come out clean or positive. So then here are some of your addition rules. So remember that adding numbers with the same sum, so if they have, same sign. If they have the same sign, you just keep the same sign, okay? So in this case, they're both positive. You add them together and you've got a 9. In the case these are both negative, you can kind of forget about the negatives for a minute and be like, okay, well, let's just 2 plus 9. 2 plus 9 is 11, and you keep that same sign. So if the signs are the same, it's actually relatively easy. Think about the absolute value of those numbers, add them together, and keep that sign. The challenging part is when they have different signs. So adding numbers with different signs says subtract the absolute value and use the sign of the greater or with the greater absolute value. So in this case, in this one, you take the absolute value of both. So the absolute value of negative 8 is 8. The absolute value of 12 is 12. You then end up actually subtracting them. Okay, so you always want to take the larger and then subtract the smaller. Well, 12 minus 8 is 4. And we keep the sign of whatever number was the largest after we took the absolute value. So in this case, 12 is larger. 12 was originally positive. That's why I say positive 4. Same thing we go for this one. Okay, you got 3 plus negative 15. If I take the absolute value of each, you've got 13 and you've got 15. You take 15 minus 3, which is 12. But the original 15 was negative, so that's why my answer then is negative 12. You always keep the sign of the greater value or whatever the greater number, the greater number after you took the absolute value. So let's go ahead and look at adding these real numbers, okay? So looks like in problem A, we've got negative 3 plus negative 16. Now, if I look back at my rule, these ones fall in the category that they have the same sign. So I can think about the absolute value of each one of these numbers. Well, the absolute value of negative 3 is a positive 3. Remember, anything negative becomes positive. And I'm still going to have an addition sign, and negative 16 becomes a positive 16. So what I do is I just add those two together. 3 plus 16 is 19, but both of them originally started with a negative sign, so my answer is going to be a negative. So negative 19. All right, B then though, I can already tell that I have two different types. I have got a negative and a positive number. So in this case, I want to take the absolute value of each. So the absolute value of negative 13 is 13. The absolute value of 7 is 7. They're opposite signs, so we subtract. So I know it says addition, but in this case, we end up subtracting them. So I'd have 13 minus 7. 13 minus 7 is 6. And then I keep the sign of whatever was the larger absolute value. So 13 is larger than 7, and the original sign of 13 is negative. So now I have a negative 6. Okay, I know it gets a little tricky as you go through, so again, feel free to pause at any point and review those rules, or let me know if you've got questions. I can always chat with you the next day or when we get around to doing the practice assignment. Alrighty, and C then. So C, we get decimal points, and they are opposite signs. So remember, in your opposite signs, we need to take the absolute value of both. Well, the absolute value of 6.2 is 6.2. Absolute value of negative 4.9 is 4.9. They're opposite signs, so we subtract. So I'm going to take 6.2 minus 4.9. We're going to move this over. We're going to do our long subtraction. So I end up with 1.3, and I'm going to keep whatever the sign was that was the original sign for the larger absolute value. So the larger absolute value, when I look at these two, is 6.2. The original sign for 6.2 is positive, so my answer is going to stay positive as 1.3. Okay. Feel free again to write down any notes you need, and make sure that you're practicing along with me. All right, let's keep looking at some of these rules. Gotta move myself around so we can read them. So two numbers are opposite if their sum is 0. A number that is opposite are additive inverses and are the same distance away from 0. They have the same absolute value. So numbers that are their inverse property of addition, that's another property, or you could say they're opposites. So you're going to have 6 and -6. Remember, if you had a 6 plus a -6, if you think about their opposite signs, you'd take the opposite value of both, so 6 and 6. You end up subtracting opposite signs, so 6 minus 6 is 0. And so that's what they're talking about, how this is their additive inverse. Okay. Then, though, if we've got, so here are our subtraction rules, so we can continue practicing our subtracting. It says to subtract signed numbers, you can use the additive inverse. Subtracting a number is the same as adding the opposite of the number. Yes. So to subtract a number, add its opposite, and then follow the rules for adding signs. So basically what we do is we change all of our subtraction into adding the opposite, because this is our additive inverse, and that's why we talk about them together. So all our subtraction we're going to change to adding the opposite. So let's go ahead and look at some subtracting. Okay, so subtracting our real numbers, we are going to end up adding the opposite. So in this case, I would have 7. I'm going to change my subtraction to add -10. Okay. You can always use a number line too, if that's going to be a little more helpful as you go through and thinking about going the other direction. In this case, though, if I'm changing it to adding when we're opposite signs, I think about their absolute values, and then I subtract the two. So I take 10 minus 7, because 10 is larger, I get 3. 10 was the larger absolute value, its original sign was negative, so I have an answer of -3. All right, let's look at a couple more. I'll probably breeze through these a little bit because I want to be able to get to the last example. But this one, again, I want to change it to adding the opposite, so I'd have -3. I change this subtraction to plus, and I change the -12 to a +12. Opposite signs again, so I think about their absolute values. 12 is larger, so I'm going to take 12 minus 3. 12 minus 3 is 9. 12 again was larger once I took that absolute value, and the original sign was negative. Oh, sorry. This is tricky. So in this case, the original sign was negative, but I want to actually look at what was the original sign once I made it a positive. So don't go back and look at the one where it was actually negative here. In this case, then, this is actually going to be a +9. So this rule, when you want to look at what is the actual value of that, you know, taking that absolute value, look back at the addition, don't look at the subtraction. So I already went ahead and looked at did the work for these next two. So when I change these to addition for C and D, so I changed the adding it to the opposite, they end up being the same signs, which makes it a little easier for adding. So in this case, I'd get -4/8, or you simplify it to -1/2. And then in this case, again, and minusing a negative makes positive, I just add the two positives together and find my solution. I'll make sure I have enough time for that last problem here. All right, so our last problem. So in this case, it says I've got a biology application. So here's our real life application. It says an emperor penguin, those are those super tall penguins, stands on an iceberg that extends 10 feet above the water. So here's our little penguin, he's 10 feet above the water. The penguin dives to an elevation of -67 feet to catch the fish. What is the total length of the penguin dive? So here's our actual problem, and we'll underline it. Things that are going to be important are this -67 and this 10. So he's going to go from 10 all the way down here. So what we're really going to do is we're taking 10, and he's going down. So he's decreasing in elevation, so we're going to subtract it. Well, to change this, we change it to adding the inverse or the opposite. And so I end up adding a +67. So to get how much feet he went completely down all the way down here, is I add the 2, and it was 77 feet in his jump. All right, so let me know if you've got any questions. Again, I only keep these to about 10 to 15 minutes, and we're about at that mark. I will catch you guys the next day here as we practice using our integer rules.